Okay, so so basically considerations within the implementation. If instance of the class doesn't exist, the new instance is created. Instance already exists, simply its reference is returned back, right? So of course, singleton constructor must be private or protected. That's an interesting point, just a very simple point, but an interesting point, is that sometimes you want to rely on the model of the singleton and be able to further extend its implementation. You know, you could use different kinds of singletons in your system. There, of course, they all have to be able to call get instance, but you know, sometimes if you want to have this direct access to the instance and you know, be able to create other types over there, you have to make then the instance protected, right? And you want to probably have this protected as well, so that you can allow subclasses of this singleton superclass to still access the actual instance and its constructor, right? So this is just a little detail that if you do plan to have this as a base class, as your base superclass, and have some subclasses doing some real work with the singleton, you know, concrete version of it, then you would want to make these two protected so that subclasses can still access this and use both as they choose. Right? So that's why we say protected or private over here. And the singleton pattern must be carefully constructed in multi-threaded application. So we really did give it enough attention to say that we actually use this mutex class right in our design, which relies on this reentrant lock, which is coming from Java concurrent library, and it's one of the locks in the system, and the type is reentrant lock. So reentrant lock is the actual type that we use over here to construct the reentrant lock and rely on it to provide mutually exclusive access. That's where the name is derived from, right? Mutex, to get access to that critical section. So that makes this get instance very happy, because we can say we can have critical section where we can guarantee that only one thread of execution gets to see this at any given time, and therefore it's thread safe. All right, so these are basically the considerations that we used in our sample. Over here, there's a singleton sample which is written in C++, but we've written our own sample in Java. So if we have time at some point, we may want to revisit this and take a look at this. But it's, you know, it's quite simple. Same idea: get instance, lock, unlock, and so forth. Right. So I'm not going to spend much time on this. As we already said, that we want to maybe plan for subclasses of the singleton, we want to keep our singleton data attribute, static data attribute, and constructor protected, right? So because oftentimes if you have an abstract factory, which we already talked about early in this class, if you want to use an abstract factory that manufactures instances of other objects, it's very likely that you may want your own abstract factory class in the system to be a singleton, to be just one unique instance, so that someone, before they can manufacture objects, they have to get instance of abstract factory. So your abstract factory may well be deriving itself from the idea of the singleton. There are other creational patterns that could likewise be implemented as singletons. And the next design pattern that I would like to explore, possibly today or possibly next week, is this object pool. Okay, so object pool basically takes this takes this idea of a singleton class to the next level by basically adding the idea that if we have this object pool, okay, object pool idea is that instead of having a single instance of something, we can have basically a collection, right? Instance collection over here. So we can use it to manage the whole collection of objects of a particular type, right? So for example, so that would typically be deriving from the singleton class, and the implementation adds other methods which deal with the object pool. So that's our next design pattern to look at. But the idea is, for example, if you're running some sort of simulation, right? Simulation scenario of some sort in a simulation program, what could happen is that in the simulation, say you have your simulation, and you want to display some sort of animation, and animation represents, say, like bugs running around the place and interacting with one another, right? Or it could be visitors in a building or something like that, right? So each single one of these visitors can arrive and disappear and have their own lifetimes, right? But you could potentially use basically a pool of these objects, which essentially, are references to actual objects in this animation screen, right? But you don't want this pool to let these objects to be destroyed. So the object can disappear from the view, right? Disappear from the view. You want to hide it, but you still want to keep the reference to it, right? So if you want to hide some of them, to have them go away, you could potentially, you can remove anything you want from the view, but you don't destroy these objects, because the next time you want this one to reappear somewhere else, right? You use this object that already exists. And this is where you have this object pool, which essentially keeps this collection of references to certain objects. And like I said, object pool itself is then the itself relies on being a singleton, because you to be able to keep this object pool in memory as unique, you probably want to declare it as a the object pool has to be unique in the system as well, right? So that we can manage this object pool. But again, this is a set of ideas for the next set of presentations, and this is our next design pattern that I would like to discuss, because it's so closely related to the singleton. So that's to be discussed next.